Sharma, Assistant Professor Ajay Kumar Garg Engineering College. Today I am going to start with the next lecture for the subject, that is Data Communication Network KEC 063. So, today's lecture is about wired LANs. LAN means local area network. So, these are the contents of today's lecture, that is known as IEEE Standards. Then on this standard, this LAN is basically divided. LAN means local area network, a network that has been set up in a office in a very small area for providing the internet connectivity, or if you want to access any of the device, let us say printer is connected to a computer, you want to take printer. So, a common printer will be installed, and through LAN you can access that common printer. So, this is the concept of LAN, that is local area network. So, it is based on IEEE standards. There is a HDLC frame that will be discussed in this lecture, that is high level data link layer control. That is the frame that has been formed at the data link layer. Now, this data link layer is basically nothing, it is the part of the OSI model. OSI model, if you remember, it consists of 7 layers. First layer is the physical layer, then data link layer, network, transport, session, presentation and application. So, these are the 7 layers of a OSI model, and at the data link layer we are nothing, we are going to form a frame. How the frame will be formed? You have to add the header and you have to add the trailer bits before and after the data bits. Next is standard Ethernet. Ethernet is nothing, it is the part of this LAN. So, what is IEEE standards? IEEE standard is in the year 1985, the Computer Society of the IEEE started a project that is known as project 802. So, basically how this is written, this is IEEE 802 is written 802.11 or different. Let me show you with X, 802.x, which means it is dependent on application. What application you want to access? Let us say you want to access Bluetooth. Bluetooth is also a kind of network connectivity that has been provided. There is no wired connection with will be established between the transmitter and receiver, a range of frequencies that has been allocated, and this is a part of this IEEE 802.11. So, a project that is called as project 802 to set the standards to enable intercommunication among equipment from a variety of manufacturers. So, project 802 is a way of specifying the functions of the physical layer and the data link layer of major LAN protocol. So, these are the different IEEE standards that has to be considered for the purpose of providing the LAN connectivity in a office or in a place. So, this is IEEE standards. As you can see that this is showing, this figure is basically showing the mapping of this OSI or internet model mapping with this IEEE standard. And at this IEEE standard, if you can see that first layer is the transmission medium. To this transmission medium there is connected the Ethernet physical layer. So, there are different several layers are there. Then there is token ring and token bus, that is also a part of this physical layer. So, what is token ring and token bus? I have already discussed in my previous lectures that what is token ring or token bus. First thing is that this is a connectivity or a style of what you will say, style of establishing a network in a form of a ring or in a form of bus. If you remember, in case of this ring, let us say this is the first node, this is second node, this is third node and this is first node. So, this is connected in the form of ring, and whichever user is having the token, then that user has the right to transmit the data or to pass that particular data to the next user. So, this is how, let us say this user is having the data and it is having the token, then they are able to transmit the packet to the second user. Now, this will going to transmit to the next user, this will going to transmit the next user, and this will going to transmit the next user. But the basic requirement is that the token has to be there by each of the user. In case of this token bus, the whole network is divided into a kind of bus. Let us say these are the nodes, these are connected to a common backbone. This is nothing, it is the backbone. This is cable end, this is again cable end, these are the tap lines, and these are nothing, these are the nodes. So, this is the bus architecture or the bus topology, that is a part of this network topology. And in this case also, whichever node is having the token, then that particular node is allowed to transmit the data. Now, you can see in case of this OSI or the internet model, this is the transmission medium. Above this there is a physical layer, data link layer, and these are the upper layers. Now, the different controls that are used is known as LLC control and MAC control. LLC means logical link control and MAC means media access control. So, these are the different controls that are allocated to each of the users, so that they can transmit their data. Now, above this physical layer there are three different layers are there, that is related to this MAC, that is the media access control. First one is the Ethernet, second one is the token ring, third one is the token bus, and this is the logical link control, that is the layer. So, if you can see that the MAC layer and the LLC layer is, if you are going to map with this OSI model, so it will lie on this data link layer. In case of this upper layer means physical layer, data layer. What are the upper layers of a OSI model? That is the network layer, transport layer, session, presentation, and application. So, these are the different layers that are the part of upper layers, and this is known as the IEEE standard, and this is known as the ISO-OSI model or the internet model, that has been shown over here. This is IEEE standard. Now, next is the HDLC frame. Different types of HDLC frames are there, like this is the first frame, that is denoted by this HDLC frame. This is address control, this is control layer, this is upper layer data, this is FCS. FCS is nothing, this means this is frame check sequence. Frame check sequence means frame check sequence means, what does it mean? That this will going to, whenever this packet will be received at the receiver side, now that frame check sequence will be checked and it will be verified that whether there is any error or not. If there is any error, then that error has to be resolved, or that particular frame has to be removed, it has to be deleted. So, this is the concept of HDLC frame. So, these are the different fields that is already allocated. This is address field, this is control, this is upper layer data, this is FCS, that is the frame check sequence. Now, these are the two different divisions of this layer, that this is the MAC header, MAC payload. MAC payload is nothing, it is the data that has to be transmitted, and this is known as the frame check sequence, and this is denoted by DSAP. DSAP is nothing, it is the destination service access point, this is source service access point. So, these two fields will basically going to have the data related to the destination, the data related to the source. So, this is source service access point and this is the destination service access point, and this is LLC PDO, that is the logical link control. PDO is there, this consists of a control data, this consists of the upper layer data. So, this is nothing, it will going to have the access of this HDLC frame. So, this HDLC frame will looks like somewhat this diagram. Now, next we will move to standard Ethernet. There are basically different types of Ethernet are there, depending on the range of data that it will going to have, that it will going to accommodate. it will going to allow for the purpose of transmission. So, the standard Ethernet, the original Ethernet was created in 1976 at the Xerox Palo Alto Research Center Park. Since then it has gone through 4 generations. So, there are different 4 generations of there. So, in the coming slides you are going to see that how this 4 generations are there. Basically, with the increasing generation, number of users are increasing. So, due to this number of users which are increasing, the requirement for the purpose of transmission, you can say, or the bandwidth required bandwidth requirement has increased. Let us say it is gigabit Ethernet is there. What do you mean by gigabit? Gigabit means number of bits that has been transmitted is increased. So, this is the concept of different generations that has been used for the Ethernet. So, this flow chart is basically showing the Ethernet evolution. This is standard Ethernet, which is going to allow maximum speed of 10 Mbps, that is 10 megabits per second. Next one is fast Ethernet, that is going to allow for 100 Mbps. Gigabit is 1 Gbps, that is 1 gigabit per second of the data can be transmitted, and this is the 10 Gbps. So, these are basically 4 generations of Ethernet, and with every Ethernet the requirement, because it is a kind of wired connection. So, different types of wires are required, so that they can going to allow for this much amount of data. Like for 10 Mbps, if you are going to compare with this 10 Gbps of data. So, as you have seen that from this to this, number of bits that has to be transmitted has increased. So, the wire that has been used for the first standard Ethernet can not going to allow this much of the data. So, basically the evolution of different cables are also there, so that they can allow 10 gigabits of data. So, this diagram is showing the 802.3 MAC frame. This is known as the preamble. Preamble is nothing, it is the 56 bits of the alternating 1 and zeros are there, which means 10 10 10. These are the preamble. Preamble is nothing, it is a kind of header, you can say. This is also written over here. This is the physical layer, header is there, which will consist of the synchronization data, so that the receiver can see that yes, that particular data has been started, the new frame has started. So, this is denoted by preamble. Then start frame delimiter is there. So, a kind of delimiting procedure is generated. So, delimiter will basically going to set the limit that particular frame has started, which is of 1 byte of data, which means 8 bits of data is there for the start frame delimiter. Next is the destination address. Destination address, it is nothing, it is again 6 bytes of data is there. Then source address is there, which is nothing, it is again also 6 bytes of data is required. Then length or type of data is there, that which type of this particular frame is there. Either it is a synchronization frame, or it will be a control information, synchronization information, or it is nothing, it can be a information data also, means the whatever data you want to transmit. So, this is also consist of this length or type of the frame. So, this is of 16 bits, because 8 bits is equals to 1 byte and we are considering 2 bytes. So, 16 bits of data is there for the length and type. Then data and padding. So, this basically consists of the original data that has to be transmitted along with the padding, which means 0 padding will be there. If it does not comes under the limit of the particular transmission, then you have to add zeros to increase the number of bits, so that it will fall in this range. Then this CRC, which means it is cyclic redundancy check. This is nothing, it is again a kind of error checking technique is there, which is of 4 bytes. You can multiply 1 byte is equals to 8 bits. So, this much data is required for the cyclic redundancy check. It will going to check that whether the particular frame that has been received is correct or not. If it is not correct, then it has to be, the error has to be removed, or that particular frame has to be removed. So, this is 802.3 MAC frame structure is there. Now, next we will see MAC frame. This is the destination address. So, whatever receiver you are selecting, let us say there are 4 users are there, 4 transmitter and 4 receivers are there. So, whatever receiver you are choosing, you have to at each frame you have to enter that particular physical address of that device, which consists of, which is being placed in this destination address. This is the source address from which particular user you are going to transmit the data. Then this is denoted as length or PDO, which is used for which type of frame it is like. Then this is data and padding which is required. Then minimum payload length, which is of 46 bytes. Now, you can see that these are the ranges that has been set for the purpose of main data that has to be transmitted. So, you can say that minimum range is 46 byte and it can be extended to 1500 bytes. 1400 bytes to 1500 bytes. So, these are the ranges in between this range that data has to be transmitted. If it does not follow this range, then padding will be done. So, 0 padding you can insert, because it will not going to basically change the data, it is just going to increase or to fulfill the requirement of length which is being set up by the device. Then cyclic redundancy check is there, this is of 4 bytes. So, this is the minimum frame length, which is 512 bits or 64 bytes, and maximum frame length is 12144 bits or 1518 bytes. So, these are the MAC frame diagram is showing. Now, this is the description of this particular frame. Frame length, you can see that minimum frame length is of 64 bytes, that is 512 bits. Maximum length will be 1518 bytes or 12144 bits. The least significant bit LSB of the first byte defines the type of the address. Type of the address means what kind of address you are having, either it is a physical address, it is a logical address, port address, or a specific address is there. So, LSB of every bit will going to define the type of address. So, basically there are 2 types of addresses are there. First one is the unicast, otherwise it will be a multicast. So, whenever if this LSB bit is 0, then it means it is a unicast address, and when it is 1, it will be a multicast address. So, these are the 2 types of addresses which are shown over here. So, you can see this is the example of hexadecimal address, which is written as hex digits. So, this is of 6 bytes you can see. So, first will be the destination address, second will be the source address, then the PDU is written over here, then the data will be there, and this will be the frame check sequence. So, this is how this MAC frame will be formed. So, this is an example of MAC frame. Length of this MAC frame is denoted by 48 bits. So, this is the data that has to be transmitted. Now, types of address, what I was talking about, if the LSB is 0, then it is a unicast address. If LSB is 1, then it will be a multicast address. So, this is unicast, that is denoted by 0th bit. If it is multicast, it is denoted by the 1 bit. So, you can see that every frame, this is denoted by the MSB, and this will be the most significant bit, and this will be the least significant bit that has to be considered, and it will be extended from byte 1 to byte 6. So, minimum length of the frame will be 1 byte and maximum length of the frame will be 6 bytes. So, you can see in this diagram. I want to show this diagram again, so that you will not confuse in this diagram. In this MAC frame, it consists of a destination address, what I was talking about. It can be a, mostly it will be a physical address, but if you want to access any of the application, like if you want to take the printout or if you want to change send the email, then it will be a specific address is there, physical address, specific address will be there, logical address is also possible, or port address. So, these are the different destination address which are possible, because every time it is not possible that you want to transmit the data. It is also possible that in a LAN a device is connected, you want to send a fax to the receiver, you want to access any of the other device, you want to access the scanner, then you have to transmit that particular application's address, that is specific address, or you want to access any other logical operation, then it consists it will be considered in logical address, or port address will be there. So, that is the case for destination address. Source address is nothing, it is the physical address only, which is device specific. If one computer wants to access any of the application, then it is nothing, it is the physical address. Length and PDO will be there. So, this is nothing, it is a type of address or the data type of the frame. It will going to decide that what kind of frame it is there. It is either the control frame, it will be a data frame, or it will be a synchronization frame. Any type of frame will be there. It consists of the data and padding information, then it consists of the CRC. So, one thing is there, in case of the cyclic redundancy check, there are different types of checking codes are there. In case of different checking codes, that will be considered for the purpose of transmission. If at the receiver side, that particular CRC code will be checked or it will be tested, so that you can find out that whether it has received correctly or not. So, that is the case for cyclic redundancy check. In that case, there will be different codes are there, that is known as cyclic code will be there, linear block codes there. In some codes there is a condition for error detection is there, and in some cases there is error correction is also there. Like in case of convolution coding, there is a condition for error correction is there, otherwise you have to detect the error and then it will be transmitted in the CRC condition. So, that is the cyclic redundancy check is there. So, in case of the cyclic codes, if we are talking about, in case of this cyclic codes, what we will have, it will be shifted in a cycles, it will be shifted in cycle, and in that particular cycle that codes will be whatever code will be generated after shifting, it is nothing, it will be again a, it will going to generate another code. So, that is also a valid code. So, after shifting there is also a valid code, that is known as the cyclic redundancy check sequence, or cyclic codes are there. In case of convolution coding, there will be a case for trellis diagram, there a syndrome will be first calculated. After that syndrome, there are different techniques are there, like code trees there, state diagram, code trellis is there. So, this is the way how this MAC frame will going to work. So, this is the minimum frame length, that is of 512 bits or 64 bytes is there, then maximum frame length will be there, that is 12144 bits or 1518 bytes are there, that is the MAC frame that has been considered over here. Now, this slide is again showing that what kind of data, what kind of address we are considering, like unicast. What is unicast? Unicast means there is only one transmitter and one receiver is there. So, that is known as the unicast. In case of multicast, there will be more than one transmitters are there and more than one receivers are there. So, this is nothing, it is the case for multicast. So, unicast to multicast. Multicast is again it is a condition for broadcasting is also there. In case of this broadcasting, when there are more than one users are there, more than one receivers are there, then they will going to broadcast the data, or it is the condition for multicasting is there. So, that is the condition for multicast. So, one bit will going to decide that whether it is a unicast address or a multicast address, and 0th bit will going to decide that it is a unicast address, means you are not going to only one transmitter and only one receiver are there. Then this is again an example of the MAC frame. This is nothing, it is the 12 hex digits are there, that is consisting of 6 bytes or 48 bits are there. If you are going to divide, because 1 byte is equals to 8 bits are there. So, that is the condition for bytes, and in terms of bits is there. This is the table diagram which is showing the unicast and multicast, and these are the references that you can consider for this particular topic, that is the wired LAN. And thank you.